Welcome to today's class where we will discuss about the part 2 on cardinality relationship. The focus is still on entity relationship model, but now we focus more on the cardinality relationship. So what is cardinality relationship? Basically, it defines the attributes relationship between entities or entity sets. Such relationship in table can take the form of one-to-one, one-to-many, many-to-many relationship. So it shows basically the relationship of data between different tables, how data are related from one table to the other table. And there are different notations for this kind of relationship. We have the information engineering style, as you can see here. These are the notations for one-to-one, one-to-many, and many-to-many, one-to-many. And so basically, this is the kind of notation that we use. This style is known as the information engineering style. We also have the Batchman style, where we have this notation to show one to one, zero to more. So these are different kinds of notation style that we have, and we have the Martin style, which is shown this way, as you can see. So one to many, many to many, or zero or more optional. You have one or more mandatory. Basically, this is a way for us to show the different kinds of notation. So when you come across this notation, so you at least you understand them, how they are related to the other, and you can see some of that written in this brace, in this bracket rather. So one to one only mandatory, and zero or more optional. So basically, this is just different styles of representing relationship in an entity relationship diagram or model. So one-to-one relationship, what is one-to-one relationship? It basically means that an entity on one side can only be related to at most just one entity on the other side. So courses can have lectures in the same room, but there can only be one course in a particular room at a time. We can have two courses going in the same room at a time. It's just one course in one room at a time. Another example of that is to show that, of course, uh, um, students can register for so many courses, but the course can only have one particular student, so we don't have duplicate students. So there can only just be one course for one student. So when you relate that between a student and a course, so a student can register for one course, and the one course can be related just to a particular student. And the one-to-many relationship, it's is about where at least let's take an example that we have here. All courses can have their lectures in some room, but many courses can share the same room. So in this part, it's also known as participation, where entities can be related to a particular entity, which one way or the other. So as I was saying earlier, so speaking about the one-to-many relationship, one entity, let's say an entity S, can be associated with multiple entities. Let's say entity Y, but entity Y can be associated with at least one entity. So that's just explaining one-to-many. And a course can have lectures in some room, but there can be many courses that can share the same room. That is one example of that. Um, yeah, with this one, as I said earlier, so one class is constituted of multiple students. So that's an example. So in one class we can have so many students. So an entity class can have multiple students. That is showing you one to many. So here the many is the student entity, and the one is the class entity. So many to one relationship is a situation where, let's say, an entity S can be associated with at most one entity of an entity Y. However, an entity from entity set Y may or may not be associated with more than one entity. So it is the opposite from the earlier one where I was speaking about. So courses can have their lectures in the same room, and many courses can share just one room. To give you another example of that, let's look at this. So many students can belong to the same class. So you say, so this is just a way to show you the opposite of the earlier one we have spoke about. So there can be many students belonging to a particular class, a particular database class, for example. And many to many relationship is a relationship where an entity can either be related to a number of other entities. For example, a course can have lectures in many rooms, and many courses can have lectures in the same room. So, for another example, we have students are associated with multiple faculty members, and faculty members can be associated with multiple students. For example, let's say we have students who are associated with faculty members in software engineering where they have one teacher that teaches database, the other teacher teaches, let's say, programming. So they are associated with multiple faculty members. These faculty members can be lecturers, for example, and these faculty members would have several students that they are associated with that attend their class. So this is an example of many to many if we want to look at it from the entity perspective. Some information about ER diagram notation. So just to recap, I think in the part one we've made mention of that. So rectangle represents an entity, and a weak entity basically you have these two rectangular diagram inside, so that represent uh, a weak entity and then the attribute. So basically, this is just a recap, just to remind you as we go further in this slide on the relationship and also weak relationship. As we go further, we'll see a practical example on how these notations are used. So, what are the steps in creating an entity relationship diagram? The first thing is first to identify what are entities. When you have a task or you're given a work to do, the first thing is to identify what are entities, and the second is what are the relationship that you can identify between these entities, and then the cardinality, like how will this relationship work? Is it one to one, one to many? So that is another aspect, which is the third one. And then the fourth is to identify attributes, basically qualities of each entities. So what uniquely identifies each entities? What are their qualities? So that is the next thing. You look at the attributes, and then once you have all this information, you create your entity relationship diagram. So let's look at this example scenario. In a university, a student enrolled to a course, let's say course database, and the students must be assigned to at least one or more courses. Each course is taught by a single professor. To maintain instruction quality, a professor can deliver only one course. So let's see how we can model this into an entity relationship diagram. So step one, the first thing we will say is that from this scenario, we have an entity students, we have course, we have professor. So that is the first step, right? We need to identify, and even in a bigger scenario, if we have a couple of universities involved and all, that university can also be an entity. But for this one, I think we'll focus more on just three entities: just the student, the course, and the professor. In the next slide, you can see that. So these are the three entities: the student, the course, and the professor. So that's step one. Now, step two, what relationship exists? From the scenario, you can see that a student is assigned to a course, and the course is delivered by a professor. So professor delivers the course. So you can say this is the relationship that we can identify. So that's the second step. And the third step is to look at the cardinality relationship. So a student can be assigned to multiple courses, as you can see with this notation symbol, and a professor can only deliver one course, as you can see with this. So it shows that it's just one. So a professor can only deliver one course at a time. So this explains the cardinality relationship, or to see how each of these entities are related to the other in terms of is it one to one or many to one, or the other. So step four is to identify attribute. In a real world, in order for you to know what attribute, because it's important when you talk about database design, because without these attributes you will definitely have problems translating that into database tables or creating your database and all that. So sometimes this come in form of carrying out interviews with stakeholders to identify entities and to understand what kind of attributes can be associated with each entities. So once you understand, okay, what are the entities and what attributes you can associate with them, only then you can move forward to creating your ER diagram or designing or finally translating that into a database and tables. So this is very important to realize that attributes, you should take your time. You can go through forms, files, or reports to critically look at it and identify what are the attributes or the qualities for each entities. So from the example we are speaking about now, we can see that we've identified an entity student, and one of the key attributes, which is the primary key here, is the student ID, and then another attribute here is student name. Same for professor. We know that professor should have an employee ID and a professor name, and course should have a course ID and course name. So these are the keys for each of these entities for us to uniquely query them. Later, when we start translating this into database tables, it becomes more clear the essence of having a primary key and foreign keys, basically. So step four now, let's put that into the entity relationship diagram. So we see that student entity has the student ID as the key and also has a student name. And the course entity has the course ID and the course name. And the professor has the employee ID and the professor name. So these are the attributes for each of these entities. So we've been able to identify them. And of course, the course can have much more attributes, but to keep things simple, we will just stick with this two attributes. You can have more if you want when designing the database. So here, to make it much more clearer, you can see that for each attribute, so we have students, the student ID as the attribute as the quality of the entity, and the student name, same as the course and the employee. So this is a better way of representing it in a really very clear, precise, and concise manner. Yeah, so the best practice for developing an effective ER diagram, of course, you have to eliminate redundant entities so and relationship. That is important, so you don't have a really bad database design. And it's important to label the entities and relationship. This should be done properly. And you need to make sure that the ER diagram that you create supports all data that needs to be stored, and you should there is this is very important. At least you should ensure that each entity only appears in a single time in the ER diagram, so you don't have an entity, for example, student, and another entity student. No, that is really a bad design. So you just have one entity at a time in each ER diagram. So and of course it's important again to name the relationship, entity, and attributes that are represented in the ER diagram. Never connect relationship with each other. That is bad design. You should yeah, this is more of clarity, using colors to highlight important portion of the ER diagram. It makes clarity when somebody wants to read your design, or if you're somebody who is working in a company and you're the database administrator or the engineer, and you're creating this, it's good when you want to present that to your boss, so it's easy for them to read, especially when it becomes like quite big, and when you have large database system designs. So these are key points that you should take note of when designing an ER diagram. So in the next class, we will speak more about database construction and usage. So speaking about SQL, so we'll get our hands dirty starting from next week with the lecture and also the exercise.